Okay, kids, welcome to Math for Chapter 14. And hopefully, we got the right one on there this time. Um, what I did do is I had to redo question 2. The first one, if you remember, it's um, I I am a equals output distance. I'm sorry, input distance over output distance. We did this yesterday too, right? And so the first one is simply if you take output distance times IMA equals input distance, and that's how you solve for input distance on here. So basically, you just take, if your IMA is 94, what is the output distance? You're actually solving for output distance is going to equal input distance over IMA, right? Because here they cancel out. And so when you have output distance, it equals input distance divided by IMA. Now, ladies and gentlemen, this may look confusing unless you do it this way. 2 equals 10 divided by 5. If you are solving for 5, right, you just change these two around. Then you have 5 equals 10 divided by 2. The same thing goes here. If you just swap these two, it's the same. All right, so coming back here, input distance divided by IMA. If the output distance is 71.4, what is the input distance? And the input distance, right, it would be 10, so that's 2 times 5, right? And that was this equation here. Output distance times IMA equals input distance. You've got, if the output distance is 71.4 and the IMA, the input distance equals, right? Input distance equals output distance times IMA. All you do is multiply the two together, right? In this particular case, first number times second number. This is the one that we had to redo. Calculating the ideal mechanical advantage of a student working in a grocery store. The ramp is 3.1 meters long and rises up 0.9 meters. On here, your IMA is input distance divided by output distance. So here, all you do, first number divided by second number. A construction worker moves a crowbar through a distance of 42.5 meters, which is a huge, to lift a load 26.4 meters. Once again, input distance, output distance. First number divided by second number. You have just designed a machine that uses a 106.6 joules of work for every 41.7 joules of useful work. This is your input. This is your output. This is your input. This is your output. So, ladies and gentlemen, when we have the efficiency of a machine, your efficiency, and that's how I do efficiency, equals work output divided by work input times 100. Now, ladies and gentlemen, so you've got work output divided by work input times 100. That is second number divided by first number times 100. 41.7 divided by 107.6 equals times 100. Edit, copy, paste. And that's it. Okay, a machine has an efficiency of 70.2, and you do what will the work output be? Ladies and gentlemen, once again, we're solving for work output, right? So that equals efficiency times work input divided by 100 equals work output. What does that look like? Because over here you have to have work output divided by work input times 100. Over here you got work input times efficiency divided by 100. Pretty simple stuff though, because over here you've got the same thing. While lifting it straight, a machine has an efficiency of 70.2, right? Times 32.5 divided by 100, and that will give you the work output. So that is simply first number times second number divided by 100. So that'd be 22.5, right? Okay, so then you go edit, copy, paste. And then here is our first question in watts. And in watts, the formula is, oh, here's your efficiency. In watts, our watts formula equals watts equals force times distance over time. And that's all you do. Well, lifting a box 2.82 meters straight up, you exert a force of 192.49 newtons for 8 seconds. It is force times distance over time. So all you do here is first number times second number divided by third number. Force times distance over time. And then that one is going to be in watts. How much work? Work is simply force times distance. So in this particular case, when you have work, right? Work, how much work do you do? And you got force and distance, you just multiply them. So question 7, first number times second number. For question 7, first number times second number. Question 8 is a trick question because you've got work and you've got time, and it's asking for power. Power is work over time. So for question 8, it is just second number divided by third number. All right, so on here, question 8, it is second number divided by third number. And you can do that, and the answer should be in watts. I think that's also the same one for number 10. Number 9 is just while lifting a box, straight up and truck, you go, yep, this is Number 9